Async await is just syntactic sugar on top of generators. Generators are the core coding paradigm. It's in a lot of languages. As a software engineer, you should learn about all these different paradigms. Whether you want to use them or not, you like them or you don't, you should learn how a generator works because you will eventually come across them in the wild, and it might be a production system. Why are callbacks within callbacks a bad paradigm? Async await forces your entire flow control to be async by default. Delimited continuations are just an abstraction upon which all flow control paradigms can be built.
Fully half of this hour-long talk is audience questions, and I think that speaks to how interesting and thought-provoking this topic is. Usually after these talks, we get together and play a board game or something as a whole group, and on this night we just couldn't. Our third eyes had just been ripped wide open and our brains were completely fried. It starts a little slow in the beginning, but I think that's because Eric knows this space. He's a wildly talented developer. He's one of the people helping to maintain redux-saga, so he knows this generator space really, really well, and it becomes conversational pretty quickly, and we go back and forth with the audience. A lot of people in the audience ask questions, and it becomes a really interesting conversation about this topic. So delimited continuations is a really big topic, and there's a lot you could say about it. And since this talk was recorded in April 2023, we've been really excited to get it out there. So here it is, delimited continuations.
Hello, everyone. I hope you all have your thinking caps on because this is going to require your full attention. In this presentation, I'm going to show you a brand new paradigm for handling async flow control in your code. So buckle up because we have a lot of ground to cover. Let's start by asking a simple question. What is flow control? Flow control is how imperative programs make a choice about what code is to be run. I want to emphasize that control doesn't just mean the visual design of the source code, but also how much control you, the end developer, has over the tools you can leverage. This is a subtle but important distinction that will be demonstrated throughout this presentation. What is async flow control? Async flow control is the same definition but using asynchronous constructs. I hope by now you're all recalling all the async constructs you know about. I'm sure at some point in time we've employed all of these constructs to express async flow control with varying degrees of success. However, some are considered by the dev community better than others. Can you rank order these async constructs in your head from worst to best? Callbacks are regarded as less than ideal. We've all heard the term callback hell, and do everything we can to avoid falling into the trap of callbacks within callbacks within callbacks. Why are callbacks within callbacks a bad paradigm? What about the image on the right is less than ideal? The Zen of Python dictates that flat is better than nested, but why? When thinking about the visual design of code, there are a couple features we care about. Readability, maintainability, the likelihood of missing an error. These are all mission-critical features of our code that require our thoughtful consideration and nothing that TypeScript is going to check. It is imperative that we are able to understand the code that we are writing and possibly more importantly, reading. Can you think about any other features we should care about? You'll read countless articles about how great async await is and everyone should use it. You probably ranked async await pretty high on your list, didn't you? However, can we think of any downsides to using async await?
I have one.
Let's do it.
So, at least in JavaScript land, usually you will still block the main thread even if you're doing async await, unless you pass off to a worker.
Interesting. Okay.
It pollutes everything up the call stack or down the call stack, so everything has to be an async function.
Oh, great. Great point. Excellent point. Anybody else? All right, let's hear it.
I think a lot of the times it's magical to a point that's detrimental, especially to people who are new to JavaScript and TypeScript. I've seen lots of times where people think, for example, in JavaScript, promises are not lazy. they will execute immediately when you create the promise, not when you await on it. And I've seen lots of bugs in code bases where they're like, oh, it's okay, I didn't await the promise, so the network request didn't happen. And it's like, no, bro, it happened when you created the promise. It's just like whether or not you await on it later is different. So I think like that syntax kind of obscures a little bit what's really going on.
Amazing. Yeah.
It makes it really easy to create sequential promises rather than you might be able to run them in parallel. So you end up sort of taking longer.
Interesting. Okay.
This is more of a promise thing, but async await can also hide the fact that promises can only resolve once. So if you await something after it's been resolved or thrown, it'll never receive it.
Oh, that's great. I didn't think about that one. Here's a list of downsides I could think of quickly. Everything is a promise. Everything is now async. The browser controls the flow of execution for async await. So it controls how it steps through the awaits. And unhandled promise rejections are pernicious. If you miss them, TypeScript's not going to tell you. You're probably thinking, wait, I don't understand. Some of these downsides are things that have never negatively impacted me. Trust your intuition. I don't know. I've run into these. But if you haven't, then maybe it's not as much of a downside. But what if I told you there was a better way to express async flow control? Would you believe me? But first, a detour. What color is your function? Did you know functions have a color? Huh? What? Yes, not all functions are created equal. They're not always interchangeable. Functions behave differently depending on their color. So as you can see in the slide, a normal function is blue, async function is red, function star I made green, and async function star, I don't know if anyone's seen that before. I never saw it before. I did research on this. I made it yellow as a combination of what? I tried to make them colored and I ran out of time. Good feedback. All right, I have the two that I'm going to talk about up top for reference. There's no problem with blue functions calling other blue functions. You'll get a return value synchronously. There's also no problem with red functions calling blue functions. You'll still get a promise that you can await. However, what happens when you call a red function inside a blue one? What I'm really trying to demonstrate here is kind of subtle, which is async await forces your entire flow control to be async by default. You must always await the result of a red function. Don't worry, this is all leading to delimited continuations and why they're so interesting. It's easy enough to just make every function red and then you await it inside the initial script, right? So what's the problem? You can see, I do this all the time. I know that there's module level async await now, but I still do this out of habit. That's all fine and good, but it has real implications to how the code functions. You're now living in the world where everything is a promise. This is interesting. I want you to think about everything being a promise and with it, all the pros and cons. Why would everything being a promise be an issue? Promises are great, right? Yes, they are. I use promises all the time. But there are a lot of questions that you have to ask yourself when you're using them. How do I compose promises to express flow control? Parallel race was one that I heard. How do I handle errors? What happens if I forget to catch every promise? How do I cancel a promise? Finally, the JS engine resolves a promise via microtask. Oh, that's interesting. We found a rabbit hole, to be sure. But here are some questions to ask yourself. What is a microtask? Why do I care that a promise is a microtask? What does that mean for the flow control of my code? I'm not going to answer these questions today, but rather ask you all to investigate further. Instead, I'll just list some examples of micro and macro tasks. I'm sure some of those are familiar. Maybe some aren't. But a promise is a micro task. Set timeout is a macro task. These have different behaviors. And you might not notice, but sometimes you get into weird behavior because of these. I mean, I know I do set timeout 0 to do stuff. I don't know why I do it. The answer's in here. Okay. Yeah, go for it.
So I'm confused. I've never seen it laid out this way. They all do work on the event loop, right?
Yeah.
So they have that part in common.
Uh-huh.
Okay. So
just when they activate depends on which bucket they're in. So there's an order that happens implicitly with the event loop based on whether or not it's a macro task or a micro task. So some things that are micro tasks might run ahead of a macro task.
They have a higher priority, kind of. Oh.
Jake Archibald has a great post on this. I have it linked in that's the number 3 at the bottom. Yep. So he does a great job explaining it.
Awesome. Thank you.
Yeah.
I thought that like set timeout and set immediate put things differently on the event loop.
Maybe.
Like,
you might be right. I don't actually know. But yeah, that article is a great entry point. So I would start there. Finally, we made it. So what are delimited continuations? I'm going to try to explain delimited continuations and fail. This is something that I'm still struggling to grok as someone who is actively using them. I don't have all the answers, and I'm not the expert. But that's okay. This presentation is designed to be an introduction and prompt you all to learn more. So delimited continuations are all about flow control. Doesn't matter if it's async or sync, DCs look the same. Delimited continuations are just an abstraction upon which all flow control paradigms can be built. I tried to define it. It's super vague because it's super vague. But continuation, the rest of code execution reified inside of a function. And delimited just means that that reified function can return a value, which allows for composition. This has like a deep history, deep academic history. When you start Googling this, you're going to start seeing a bunch of academic research. So I'm going to do a very shallow dive here, and then I'm going to bring us back up to the surface to talk about how we can actually use it. But in essence, the most common type of delimited continuation has 2 primitives, shift and reset. These are all you need for complex async flow control. And I'm going to try to demonstrate that in the next slides. But before we go any further, I have to make another detour. Yield delegates. TypeScript has basic support for generators, but not for the type of constructs we're building here with delimited continuations. This is a big problem. If we can't leverage TypeScript to resolve types properly, we lose a ton of value in using delimited continuations as the foundation for async flow control. Async await has great typing support. You await a promise, you get the value that's in the promise out on the left side. That's great. Generators typically don't have that. So yield delegates, the yield star syntax, provides a way to reach into the generator and have it output the proper type for us. It's a hack, to be sure, but it works very well for our use case. So you're going to see yield star all over the place. That's so we can get the type out. That is the only reason why you're going to see it. It has other benefits, but I don't want to go into that just yet. Finally, you might be thinking, some code. This is where things get weird. Continuation is a library built by the team at Frontside where most of the experimentation is happening. So we're going to use that as the foundation for the code. The First example I want to show is a sync example. It's just a simple string concatenation. We're just combining two strings in a template and showing the result. Okay. The entire flow of the evaluate function is synchronous in this example, and as such, we can use it like a normal function. As you can see at the bottom, we are doing nothing fancy. We're simply combining two strings together using a template function. You'll see references to k a lot in these examples. That is the continuation function. When called, it continues the yield from the shift onto the next yield statement. It is the continuation mechanism. Think of it like a callback. When you return k from a shift, the evaluate function returns that k function as its value. Inside the evaluate function greeting and thing, our values passed into it from outside the evaluate function body. Shift can be thought of as slots that eventually get filled by values passed into evaluate. That's why we have the slot function there to just sort of demonstrate what it's doing, because it's really confusing. But you've got a picture of what this looks like. Let me show you how you can do it with just blue functions. The same thing. Oh, this is just the key points that I just talked about. Huh? Are we having fun yet? Okay. Let's take a step back. How can we implement something similar using plain blue functions? We have a function return a function return a function. This is a variant of callback hell. It's not ideal, but it works for the example we demonstrated previously. Let's try this again, but using a continuation passing style blue function. Here we receive the templated string as a callback to our CPS function. This is also a variant of callback hell, not great, and in this example, completely unnecessary. But you could imagine when you start adding red functions here that it will eventually become necessary. Let's continue. Oh, that's good. Good call out. All right. Here's an async example. This is where we're starting to get into the usefulness. In this example, I just want to show how we can incorporate async flow into our delimited continuations. As you can see here, we have a shift that is just returning k. K is just a function to continue to the next yield statement. So that k gets taken out into that run. So you can call run with the value that you want to provide k. That's the left result. Now we have a right result, which is another shift. And I called the k in this case resolve, because it's very similar. K and resolve are very similar, like a promise resolve. But here we're returning a promise. So I just, for the sake of demonstration, we're returning a promise that's resolved immediately. And then we call resolve, which is the continuation of the shift. And then that goes to the final line, which is left and right. We just add the two numbers together, and we get the result out. It doesn't matter if it's async or sync. Delimited continuations can handle the flow control. The right shift returns a promise, which is what gets returned when calling run 13. All right, let me go back so it's easier. Since the return value is a promise, we can await it. I renamed shift k to resolve to demonstrate how similar it is. When you use a promise, it will always be async. When you use a delimited continuation, it might be async. Doesn't matter if the flow control of execution is sync or async. Delimited continuations handle them the exact same way. And that's really like the meat here, is we have a set of functions, we have a paradigm to handle both sync and async without needing to know all the colors right away. Okay, let's go to a crazier example. Using delimited continuations, we can compose shift to do complex flow control. As you can see here, we have an evaluate function. The first yield calls add, which then calls shift twice and returns the addition of those two shifted results. Then we have another function that we're adding together with that result of sync, which is a promise. So this is like sync, async. We're using them both at the same time, and they look the exact same inside of our continuation function. And then we have the second value, which we're just adding more values. We have a set timeout and a math random. They both get resolved. And when they get resolved, we go to the result line and add them together again and get a result. So all we're doing in this example is adding a bunch of numbers together, but some are getting resolved synchronously, some are getting resolved asynchronously. The key idea I want to illustrate here is that composition using shift is not only possible, but relatively flat and easy to do. Just showing this code on the screen isn't going to do it justice. Like I said, use the GitHub repo, play around with it. It'll make more sense when you can mess with it and see all the types and everything.
Could I ask a question on that last slide?
Yeah, go for it.
I have a few questions because my head is spinning, but is anybody else's head spinning? Okay. Yes, thank you. Okay.
My head is spinning too, just so you know.
That's great. I mean, I love it. So that's what I'm here for. So a few questions. I kind of get that the way that in the very first one that you showed, we don't have to go back to it, but it was like, I looked at the type and it said like, it was like a curried function. Like it's like a thing returning a function that takes a thing returning a function. And I'm looking at the code thinking, well, I only see one function here. But the way that works is by generators. Okay, so I got that part. For sync there, that function is a generator. Why does it have to be a generator?
Mainly for our types. It doesn't have to be a generator.
Okay. So that's like, sync is like the identity function here.
Yeah. Yeah, exactly. It's just another way to show what it's doing, and I abstracted it a little because we use it a lot.
Okay, so the reason that you need sync so it says let first equals yield, that line?
Yep.
So the reason you need sync there for wrapping 13 is not because, like, I mean, I looked at that and thought, why can't you just put 13 there? But the reason you can't is because you need the generators to have the machinery to to like pass these things around, to continue them. Okay, that's the explanation? Okay, I'm less underwater now, but
we could have just put 13 there, but it's to demonstrate.
Oh, it would work.
Yeah.
Oh.
Well, I mean, we would have to finagle this to make it work, but like it's possible to make it work. But we use the sync because we're using add as well, which needs the generator. Like the shift, when you do like on the left line,
yep,
yield shift, left-hand side, that is the sync, which then returns the k, which resolves the value that we passed in. So the shift on the left-hand side is just doing this function, which is resolving it immediately. Mm-hmm. And it's just so we can compose add with other generator functions that gets composed with shift. And yeah, it gets all mixed up in there.
I kind of get it though. If everything's a generator, then it doesn't matter if it's sync or async internally. Mm-hmm. Okay.
So, I mean, are we using generators here because we're leveraging their ability to pause a function and allow other stuff to perform work interspersed between yielding?
That, and so we can leverage async flow control. So we can drop out of the function, let it wait until it gets resolved with the k. That's how it resolves. It's like a promise.resolve, essentially. So things get dropped out of you hit a yield, and then you wait until the k resolve gets called, and then it goes to the next yield. So we're able to have with delimited continuations and generators, which is why we use them in redux-saga, they allow us to control how that that function goes from yield to yield. And we control what values get return from on the left-hand side of those yields as well. If you use something like async await, it always has to await a promise because that's just how the JavaScript engine was, like the spec was designed. So there's some assumptions there.
So like in the function add, we have two yields. In between those two yields, that allows something else to run, and we're not going to block the thread.
Correct. Yeah. Yep. It just gets kicked onto the event loop until the k-resolve gets called for that shift.
Does this result then come back after a second because of the set timeout 1 second? Okay.
If we didn't have any promises or any set timeouts, it would resolve immediately. That's the juju of how this works. We can have evaluate return immediately and be completely synchronous, or we can throw some promises in there. We can throw some micro tasks, some macro tasks, and it just knows how to handle them as long as you get them into the right structure. Yeah. Okay. Any other questions? This is great. Thanks. Thanks, everyone. All right. Here's another example. Finally, I want to demonstrate computation in a bottle, which is what reset is all about. Here we're using reset to make the counter reusable. Now we can call useCounter as many times as we want in order to create new instances of our counter. I'm going to stop there. There's so much more to learn about this paradigm, but I really want to move on and get through the rest of this. And it's really confusing. But reset is how you can get composition in a bottle. You can keep, if we didn't have the reset and we just kept calling useCounter, it would get all munged together. What? 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 I'm still very, very confused about this coding paradigm. Every time I look at this code, I get a headache. But, you know, to be honest, most end developers aren't going to be using delimited continuations directly. Rather, this tool will allow library developers to build on top of it, which is what we're doing. Let's go higher level. Effection v3. Effection is a library that was built by Frontside, or they're on the third version, which is using delimited continuations. Effection takes continuation and builds a task tree. All tasks are cleaned up automatically via a set of cancellation strategies. So tasks can spawn other tasks. Tasks can be halted, so like paused or canceled. When a task gets halted, all descendants are halted and all ancestors get halted. Effection also has higher level compositions of shift and reset, which grants us a flourish of functionality. For example, suspend, which would permanently suspend a generator function at a yield point. Why would you ever want to do that? We use it all the time. I don't want to, I can go into it, but I'll spare you. Action, which is a wrapper for shift with proper cleanup of the task. So you can do continuations and then clean the task up when it's done. There's all this logic involved in actually running a generator, which is what we're doing. Spawn is what creates subtasks. Create channel, that's like a Golang channel. It's kind of like an event emitter, but using delimited continuations. And sleep, which temporarily suspends the generator function for n milliseconds. I know what you're thinking. This is a lot to handle. I'd like to take a second for us to all just take a deep breath, because we aren't done yet. Okay, here we go. Building on top of effection, we now have a set of middle-level primitives that allow us to build any flow control paradigm we want. Using suspend, action, spawn, create channel, and sleep, we have everything we need to express all forms of async flow control. This is the one paradigm to rule all paradigms. I know it probably hasn't clicked yet, and I'm probably not doing the best job explaining its full potential. But give it time, stay engaged, join the front side Discord where we're actively developing this technology, if you're interested. Jake Archibald recently wrote an article about unhandled rejections. I don't know if anybody read it. Show of hands? No? Anybody? Okay. It just came out like a week ago. In it, he talks about the use case of, or came out a month ago. In it, he talks about the use case of wanting to fetch book chapters in parallel, but process them in sequence. So we already kind of talked about this a little bit, where you can activate a promise without yielding to it, which is what's being leveraged here. So as you can see, we're mapping over all the URLs, we're calling fetch, and we're getting the JSON blob out of it. Then in the 408, we're awaiting that those promises are getting done in sequence. So chapter 1 gets waited on, then we go to chapter 2, then we go to chapter 3. But all of those fetches are getting called in parallel. It's kind of interesting. I actually didn't know that you could do this. I didn't know about 408 of. I learned quite a lot in this article, actually. He goes on to describe the potential for bugs because of unhandled rejections. Below is the quote-unquote final solution that he added in his article. He just added a line to just make sure he adds a .catch to every fetch. The key point I want to make here is the end user needs to be thoughtful about the promises they activate, while at the same time leveraging the JS engine to handle async flow control for them. It's this weird middle ground where async await is those functions are getting run automatically by the browser or the JS engine, but they're not making sure that you handle all catches, that you handle all of these promises. So you have to know to do it yourself. This is tough because there are no signals, not even in TypeScript, that aid you in detecting unhandled promise rejections. Ouch. Maybe there's an ESLint thing for it. I don't know. There is? Okay. I don't use it. Let's go further. Let's go higher level. Now I'm like slowly getting us up to the surface. starfx builds off of effection in order to be used inside the browser. It is an experimental library that could eventually supersede redux-saga, as well as React Query and more. Using starfx, we could do something like this. Here, we use a couple APIs from starfx to do the same thing that you saw in the previous example, but with a bunch of safety mechanisms built in. And we can build these safety mechanisms in because we have control of how the generator steps through the yields. You don't have that kind of control with async await, which is why people use generators. Request is a wrapper around fetch that will automatically abort when a task is halted. So we have an abort signal that we make sure every fetch inherits. So when a task is halted, we call that signal .abort, and then it aborts the fetch. Parallel is a function to call all functions it receives at the same time and returns a channel that the user can loop over in sequence, or even as they become available, dealer's choice. We can build any version of this as we want, again, because we have the control. Further, parallel will never throw. It automatically catches errors and returns a result type for each request. Result type is inspired by Rust result type, which is highly regarded. I don't know if anybody knows about it. Feel free to look it up online. To be clear, this is a proposed API. We're actively working on the initial implementation here. And throughout the whole stack, we're actively developing. Continuation, effection, and starfx are all being actively developed at the same time. So what do we have? No uncaught exceptions. Code is just as simple to understand. Further, we automatically pass an abort controller signal to all HTTP requests because of the request FX we wrote. When a task is halted or crashes, we trigger the signal to abort the fetch, which is what I said previously. Automatic cleanup. We're not restricted to the async flow control promise and async await provides. We're able to create as many different flow control structures as we want, all leveraging delimited continuations and these two functions, shift and reset. We're just getting started. This is an area of active development and a foundation on which we can build any async flow control constructs. I don't know if it's clicked for anyone else, but it has pretty much consumed all my time and energy because it's so exciting. This is a list of things that we're actively building right now. An inspector/debugger for effection, so you could see the whole tree of tasks and start and stop and restart and do all those things with individual tasks. Starfx system for Redux, basically a replacement for redux-saga. Query and cache management, a replacement for React Query. A web server, replacement for Express. And a view library, which would replace React. All of these things, these libraries, use async flow control one way or another. We're rebuilding them with this foundation of delimited continuations. And the idea, the hope, is that it's going to be easier to read, easier to write, less code. That's the hope.
There's like a elephant in the room, to me, anyway.
Oh, let's hear it.
Do you know what I'm going to say?
No.
Okay. You're like way too amped about this. That's a good thing, though. I like generators because like I sat down and tried to understand them one day, and they're not really that difficult. I loved using redux-saga back when.
Good for you.
That's Rob's. You give that good for me to Rob because Rob got me started on it, and it really opened my mind. But what I've noticed, and what I had noticed with using redux-saga, is that people are very afraid of generators. Yeah. This whole world, I love this picture, by the way. Is this AI generated?
Midjourney.
Midjourney, okay. I got to check that one out.
I Googled Midjourney plus Tree of Life. Because I don't have access to Midjourney and I didn't want to subscribe, so I found a Reddit thread that had it.
That's awesome. Okay, that's one way to use it, I guess. So like the question I have is, it seems extremely ambitious, and I'm here rooting for you, but even if you manage to rebuild React and Express and React Query and redux-saga and make a debugger, you still have that problem of like, well, but I don't like generators. I don't understand, someone saying I don't understand generators. And like, I'd love to hear your thoughts on like how to work through that, or maybe you could tell us what your experience has been teaching people about generators, and maybe there's like a cheat code to get someone to understand it better. Do you see my question?
Yes.
Okay.
Yes, I do get this question a lot. I impose redux-saga on at every company, at every product. I use it all the time. I love it. But it is an acquired
So
taste.
you're some people's worst enemy is what you're saying.
Yeah, maybe.
Record food service.
Good point. The async await and generators are not different. They just look a little different. Async await is just syntactic sugar on top of generators. Generators are the core construct coding paradigm. It's in a lot of languages. As a software engineer, you should learn about all these different paradigms. Whether you want to use them or not, you like them or you don't, you should learn how a generator works, because you will eventually come across them in the wild. And it might be a production system, it might be a production legacy system. So I feel like I don't want to say duty, but that's my pitch, is that it's not like we're using CoffeeScript and it's a weird thing in CoffeeScript. This is vanilla JavaScript. You can run this in the browser, in the console, and it will work. It just so happens that async await makes things so much easier, but it also limits you. And that's like the trade-off that you have to make. It's like, how limited do you want to be? For the most of the time, you probably don't care.
That's definitely my favorite part of your pitch here, is that there are so many footguns. Like how many did we label? And you still came up with more. There's so many footguns with promises. And there are almost, the footgun with generators is that, like, it's the first hurdle. Like, if you can get past the first hurdle of like, what is a generator? How does a generator work? Then it's kind of gravy from there. There's not really like you said, it's pretty simple after you get past that first part.
Yeah. And, you know, the ECMAScript, like the ECMASpec, they're working on better flow control for async await and promises, and you can wait for that. Or we can write 150 lines of code and then build whatever async flow control paradigms we want off of it. The continuation library is 100. It can actually be implemented in 15 lines of code. Now we add all these production level checks and balances and things that we have to do to ensure that we don't get stack overflows, because by default, generators and continuation is synchronous. So you can get that value out immediately from the evaluate if you want, if your code allows. So it's easy to get in stack overflows. So we have all these checks to make sure that doesn't happen, or is very unlikely to happen. So that 15 lines of code blew up into 150. But now we have something that we feel like is going to scale and just be the rock bed for all these other pieces of code. These libraries are very small. And that's sort of the goal. Like redux-saga, I just converted it to TypeScript as like a trying to learn how it all works, because it's really, the code base itself is actually really complicated. It's using callbacks within callbacks and all that. That was about 2,300 lines of code. All three of these libraries combined, I don't know, you're looking at 500. Like I'm at the point now where I'm actually almost replacing redux-saga completely. We're almost feature complete for the most part, and significantly less code. And it's much easier to read and understand, because throughout effection and continuation, there are no callbacks. You're just yielding to wait for the value to be done, and then you continue.
So I think I know your answer already, but it seems
Answer it for me, please.
It seems like via this combination of libraries, we've implemented another virtual machine in the JS userland. Very similar to, like, I think it's called Gleam, the Gleam VM that Ember runs on. To me, you aren't really that far from writing another language with these primitives. So why not?
There are languages that are coming out that take a lot of the concepts that we're building on top of and bake them into languages. I really like TypeScript. I want to run this stuff in the browser. Everyone uses TypeScript for the most part. Everyone wants to use TypeScript at least. So that's why not. Having said that, what is really fun about delimited continuations and what we have with continuation is we can bring other language constructs into TypeScript. For example, Golang has a defer expression. Really handy. What we have in TypeScript is try catch finally. You put everything in the finally to do cleanup. But we could actually we could create a yield star defer. It accepts the generator function, and then when the function body is done, or the task is done even, we can call that defer. Literally implementing that was 5 lines of code. So we're bringing result type in from Rust. We're bringing defer in from Golang. We're going to look for other things as well to sort of make TypeScript even better. I like TypeScript. I mean, most of my work is now in Dino, and then I convert to NPM or whatever whenever I need to.
Yeah, when we were using redux-saga, we absolutely ran into that TypeScript limitation where the yields were never safely typed. So I'm kind of curious how...
There is a library called typed redux-saga. It hasn't been upstreamed into redux-saga because of compatibility issues. Redux-saga is essentially like stable at this point, and we don't really want to mess with it. Typed redux-saga is opt-in. You install it, and then you can use the yield star to get the results out, which is what we use for my work. Thanks for that question.
Super happy you can have defer, because there's like also footguns with try finally. Like if you return in a try finally, it'll do like a double return, and it actually will override the return you have in the try. So it's weird stuff like that.
Yeah, exactly. Like try catch finally, I could go into it. I personally don't. Oh, sorry. I personally don't like try catch finally. It adds a level of nesting. You have to have a let variable to get the data out of the try catch finally. There's a whole cadence of boilerplate in order to like make that work for some use cases, and I'd rather just flatten everything. So we're playing around with the idea of making everything safe by default, which it doesn't throw. It just returns the error result type.
Good transition. I have 3 questions. That's the second one. Can you go back to the previous slide?
Sure.
Or I guess 2, maybe 2 back. Okay, here. So this is, there's no more catching an error. There's no throwing. You basically like return an error. Like, so if it's result not okay, then the error is in the result. Love that. Like Go and Rust have this, and like the control flow of like raising an exception is you can't type it. You don't really know what errors are going to be thrown. So this for me is like a huge benefit.
Yep.
So that's more of a comment than a question, I guess.
Yeah.
But I do have a question.
Okay.
What does the stack trace look like for this? Does it look like a normal stack trace?
So I've been working in the browser with starfx to get it to work with, so I can replace redux-saga, essentially. If you use Vite, not Vite, it looks amazing. It's flattened. Yield stars, you're not yielding to a generator. It's actually reaching into the generator and then going through the yields. So the call stack looks really clean. To me, it was super readable, so much better than redux-saga, how it is now. And the other benefit of using continuation and effection and starfx is since the code is smaller, it's easier to understand. And we're also able to fix the things in redux-saga that are really hard to fix right now without major breaking changes or major rewrites. So stack tracing is one big one in redux-saga. Stack overflows were another big one in redux-saga that we just couldn't fix very easily. So we didn't try, or we tried and failed. But stack traces look really good. At least in the browser with Vite. I have a feeling Vite is doing something magical.
It always does.
You talked before about in the delimited continuations how you can kind of mix async and sync. Do you ever, when you're using that style, does it get kind of confusing whether you need to await or then the result versus when you don't?
Yeah, I mean, that's a great question. When I was building the slide deck, I was thinking the exact same thing. Like I'm talking about the functions have colors and that's not good. And you're making everything color red. What we're doing in the continuation effection in starfx is coloring everything green. So you boot it up and you get everything into the green generators, the generator functions, and then everything's basically a generator. So it has the same polluting issue where everything just gets polluted into a generator. And I mean, I think there are probably going to be issues where you don't know what you have. If you write the code properly, and I think we have in our libraries, it's pretty clear what's going on. And we barely have any like built-in support for promises. So everything's kind of synchronous by default in our library code. So yes, it's probably going to be confusing, and I could see a footgun there for sure.
Since this is a TypeScript meetup, like how well is TypeScript supported here? If you try to, like, will you know whether you get a promise or you get a synchronous value out of your generator?
It tries to do everything it can. So it does infer whatever thing you pass into it. There's some hand-holding to get it to the right value, but I would argue that certainly coming from redux-saga, where we do have types, but it's in a separate file, it's much easier to understand what's going on. We have a couple constructs for the generator. So these generator functions don't return a generator type. They return a computation type. And that has very strict definitions of what can be yielded. So it tries.
Is it possible to do a Go-like thing where creating other threads and moving this work onto those other threads to avoid like, because if you didn't if you had like a loop over like a million things and you didn't have any yields in there, you'd block the thread. Is it possible to use something like this to have a runtime that moves things into other threads?
Like a service worker, or
like with Go, it creates one thread for every CPU core you have.
Yeah, yeah.
And then the Go scheduler will run your Go routine on threads that there's work. Is that possible to do?
Well, with like Node and JavaScript, it's all a single thread.
You can't create a new thread? I have never.
You can do service workers.
So for a worker runtime to work for this, everything that's being shifted onto their async call stack would need to be serializable. But because there's a continuation function passed to shift, that's not currently possible.
That's
Unless
great.
you're doing like some trick. You can kind of do this. If it's a pure function, you can call like function toString, get the source code of the function in the worker into value and call new function. It's technically possible. It's not a good idea. You lose a lot of everything really with that approach.
I mean, that's one reason why I really like Redux. And I could go into this. I can talk about, I should probably save this for another talk, but Redux has a paradigm where you try to make your state JSON serializable. You also try to make your actions JSON serializable. So I built an Electron app where they communicate via Redux. So you could have a main thread and a renderer thread that communicate via Redux, and then they both just are listening for those actions being dispatched and then call it. But continuing a generator function across that boundary is not really possible, as you pointed out.
So I'm curious about testing, because in redux-saga, that's like, I don't know if the docs are still like this, but back in the day, reading the docs, it was very big on like, what's the point of all this? The point is testing. And I was kind of persuaded by that. Is it sort of same rules apply here as far as being able to abstract and mock out different continuations?
So yeah, this is a great question, great topic. I would say that redux-saga tries to sell you that testing is really great in redux-saga. And there are aspects of it that are great because you're yielding to a function that just returns JSON. So if you run your generator in isolation, you are just spitting out a bunch of JSON objects, essentially. The problem is you end up testing the implementation because you have to tell your test at each yield point what the result should be of that function. So on one hand, it is easier because you don't have to do like any crazy mocking. You just tell it to return a certain value. So if you're like doing a yield call fetch, so you're calling fetch, you can just have it return a JSON blob if you wanted to. You can have it return anything you want. That's part of the power of generators. But then you have to test the implementation. And that's the thing that people don't like about redux-saga testing. Having said all that, starfx is going to have the same style where you're yielding to a JSON blob, essentially. So like yield call, yield request, that function request just returns a JSON object that then we have a runtime that goes through and provides the correct value. Okay. So it's, yes, testing, it's going to be similar testing to starfx, but I'm brainstorming how to make it so you don't have to test the implementation, which is like the biggest critique of using redux-saga for testing. If that answers, I hope that answers your question.
All right. And the last thing I was going to say, so it's not merged yet, but TypeScript is exploring a syntax for typing what a function throws. So in the, like right after the parenthesis that ends the parameters, you would say like throws, you know, custom error or whatever. Personally, I think maybe you agree with this, Aaron. I think it's kind of like lipstick on a pig type of situation where like we can try all we like to make this better, but after seeing, like, I'm glad you mentioned the Rust result type. Like for me, after having worked with the like Rust and worked with the result type, I don't want anything else. It's all I want. It's the best way. And I thought it was interesting that you compared it to Go because like I think Go's is very different, but Go also. the errors are values, so you return the value, and even that is still better than the situation we have in Java and C# and, well, JavaScript too.
Yeah.
And many others.
Yeah, it goes into the try catch finally. You're throwing an error, which is a data signal that can.
I had no idea the finally return will overcome the.
Yeah. So, I mean, the general concept, what I would describe is treating side effects as data, treating errors as data. It's been my experience that yields the safest results.
Yeah.
And I am heavily trying to bake that into all of this.
Awesome.
I have tons of questions, but I'll try to reduce it to the bigger ones. So I think Dimitri hit a lot of the same thing with talking about testing already, because my experience with unit testing, something that was using redux-saga, was you make a change to your program to like do another yield call in the middle, and then you go to the unit test and there's 17 yield calls, and I have to figure out which one to add something to change in the middle. So can you just first like explain it? You seem very familiar with this problem.
Yes. Yes.
Can you explain kind of like what your approach fixes with that?
Yeah. It doesn't.
Okay.
I'm literally falling into that same trap. The only reassurance I can provide is that redux-saga did not provide any test tooling by default. They sort of said, user land, figure it out. I'm going to have something baked in to starfx that is like, this is the way to test. And I have a library that I use with redux-saga that makes that problem a lot easier to understand. You can skip yields and just have it return a value, and you don't care what it actually returns, like what the yield, the right side of the yield is. Things like that are like ways that you can get around it. Of course, you're still testing the implementation, which is the core of like what you're saying is an issue, is like, I make a change to the code, the test fails. But the like behavior, the actual behavior of that function is exactly the same. You could have just changed the implementation slightly. The tests are failing, and now you have to change the code in 2 places instead of 1. How is that useful? It's not.
Like, it's just, isn't the solution like inversion of control or dependency injection? I mean, if you're just, anytime you're just saying like this one call should be this other thing deep down, it's going to suck no matter what you do. Like, you should just pass like a client or a, yeah.
You could, yes. That is one way to get around it. The problem, there's like all kinds of issues, like, because redux-saga uses Redux, one solution is to always boot up a Redux store and make sure that generator has the Redux store. So when you see a yield select, it knows to just reach into the Redux store and return whatever value you passed into it. That's not how it works by default. The yield select just says, hey, what value should I put in for the left side of this yield? And then you have to supply it. The other possible solution is, because starfx, the idea is to use Redux as like its data store. There's only some things that you really care about, and there's some things that you don't care about. You don't care that you're dispatching actions. You just care that the thing that it's dispatching is doing the thing it's supposed to. So you can do stuff like that to say, I only care about certain yield statements, but not others. And that's sort of the idea that I'm going to be running with, is like figuring out a good way to just ignore some of these yield calls and not have to assert every single one of them, which is what you have to do by default. Yeah, dependency injection is definitely another one for sure.
So the second thing I wanted to talk about was, you mentioned query and cache management. Obviously, that's great in the context. Like in your previous example, you had a pure fetch going to like some sort of REST call probably. In our system right now, we're trying to work with GraphQL. Then you only have one call that can kind of specify all the things it needs. So I'm curious, like, what your approach brings to the table with that, where you already kind of have a more flat flow because you're not waiting like 20 calls to different systems.
Yeah, that's an interesting question. To answer it specifically, we haven't really thought about GraphQL too much yet. Theoretically, it's possible to do anything we want to do because we control the flow control. I don't know. Do you have any ideas?
Yeah, and like you can do GraphQL calls in native fetch pretty easily. Like you don't need to use the Apollo client library. So like I can see if you needed to do multiple GraphQL calls and handle like one thing synchronously, let the other do async. I could see where that would come in and be kind of helpful with your approach.
Yeah, we're primarily going after React query.
Yeah.
For right now.
Cool.
That's what a lot of people are using and what I use or would use. So GraphQL might not, like if you're using that inside of React components, might not be useful if that's all you're doing.
Yeah.
But like you said, if there's coordination, there could be a use for starfx or a generator style hook that you can just run things in tandem.
Yeah, very cool. And then my last question was, I hear Redux often in the context of state management. This seems more like state management in the context of the state of your processes. So I assume this doesn't apply quite so much with state management. Like zustand is taking over a lot as far as I know with like Redux's base stuff. So does it have any parallels in that sort of state, like just pure the state of the application management, or is it more just like the state of how much stuff you've processed?
Yeah, that's a good question. I would say there's two different ways we're handling state in effection, continuation, starfx. Starfx is dealing with application state management via Redux. So that's where that style of state management would happen, is inside of Redux. Continuation and effection, we have state there as well, but we're storing values on the frame, which is a lower level construct that we have. So when you run the evaluate function, it creates a frame, and when you spawn a task, it creates another frame and runs that. And that frame object has a context variable that can hold data, and that data can be used anywhere throughout that generator task tree. So for example, you can attach the Redux store to the parent frame, the root frame, and then that is available everywhere. So we can have the Redux store available inside of a hook, inside of a generator function, and they're not really like, there's no explicit connection there. We just mount the Redux store once, and then you have access to it in the generator function. So you can have access to all kinds of stuff that you want. And the context is very similar to React context, and that's where we're modeling it off of. Yeah,
so like for the context of your view library thing at the bottom, so you might not have this built yet, but then the concept would be something like you would have some provider that would provide this generator system that with the store you mentioned, and then you could use that in whatever hooks that you set up.
Cool. If we recreate the view library, the local state would probably be stored in the context of a frame.
Yeah.
As an example.
Cool.
Yeah.
When am I going to be able to download this from NPM?
So I made the repo public. The other two repos are already public, continuation and effection. starfx is the one that I've been primarily developing. I made the repo public for this talk because I wanted you to be able to at least see it. It's not ready yet. I have an example folder that has something running that works exactly like Redux, or very similarly to redux-saga, I mean. So you can play around with it if you pull the code down. When is it going to get published? When I have enough time to finish it. There's like there is stuff at lower levels that we're working through actively right now. Once we iron those out, like some of the proposed API. The proposed API I have here is relying on lower level constructs that we need to build out first, that we haven't done yet. Once that happens, I should have everything I need to release starfx. Effection v3 is already released. You can download it through Dinoland or NPM. Same with continuation.
Awesome. Thank you.
Yeah. I did want to do a quick shout out to Aptable, which is the most successful pass you didn't know existed. If you're interested in using it, feel free to message me or do hello@aptable.com. That'll go. And then also front side, that's where like most of this development is happening out of. They have a pretty big open source like community that they're trying to foster. So they have their Discord. That's where I'm at. I'm in that Discord, hanging out, working through all of these problems actively. So if you're interested, come check us out. Yeah, that's it. Thanks.
All right.
Cool.
My mind is blown.